In this lecture, we would be doing the introduction for TPOT. Now, what is TPOT? TPOT is a Python automated machine learning tool that optimizes machine learning pipelines using genetic programming. TPOT will automate most tedious part of machine learning by intelligently exploring thousands of possible pipelines to find the best one for your data. Tree-based pipeline optimization tool was developed using strongly typed genetic programming to optimize analysis pipeline for data science problems. It allows sklearn search algorithm to find best patterns, evaluate pipeline, and randomly changes pipeline to optimize. So now you know that if you have a large data set and you have to, let's say, train thousands of object detections, you can rather go ahead and choose TPOT and train those models, and you can have a pipeline of thousands of models, and it will basically optimize and give you the right pipeline that you need to make the right prediction. All right, so the next one is how we perceive TPOTs over here. This is basically a view of automated automation done by the TPOT. So let's consider we have a raw data, then we do the data cleansing. Then in the next part of the machine learning pipeline, we have these three steps, which is feature selection, feature pre-processing, feature construction. And once the pre-processing part is done, then we do the model selection. In this case, you can have ensemble model selections, right? And then finally you do the hyperparameter tuning to optimize your model, and then you do the model validation. Now, similarly, let's look at one more picture, which basically outlines the TPOT machine learning pipeline, right? Over here, we have entire data set, right? This is basically indicating multiple copies of the data set that can enter pipeline for analysis. Then on the top corner, we are doing polynomial features, which is pipeline operators modify the features. Then we have PCS, which stands for principal component analysis, which basically allowing you to modify the data set flow through the pipeline operators. Over here, you can reduce these feature sets from, let's say, 20 features to 2 or 3 using the PCA. And then once you combine those features, you do recursive feature elimination. And once that is done, finally you're left with the classifier. And this final classifier classification allows you to make the classification on the final feature set. Now also make a note of it that AutoML algorithms aren't simple as fitting models on large data sets. They are considering multiple machine learning algorithms like random forest, linear models, SVMs. In a machine learning pipeline with multiple pre-processing steps, missing values imputation, scaling, PCA feature selection are performed. And finally, you also perform the hyperparameter tuning for all the models and pre-processing steps, as well as the multiple ways to ensemble or stack algorithms within the pipeline. So also know that when we start our exercise, we will be building multiple machine learning models in a stacked approach. And then also we would do a training of our data set using the TPOT, and then be able to compare how does my TPOT model outperforms the stacked models. Now over here, just to give you a brief overview of the TPOT classifier, the constructor itself has a bunch of arguments, and the one that I want you to pay attention is, let's say, the target, which is the target name, name of the target column in the input file. Mode is TPOT mode, whether TPOT is being used for supervised classification regression. So depending on whether it's a classification regression, you would set the mode value, right? It would be a binary value. Then the output file, again, you want to pass the name of the file to export the code to the final optimized pipeline. Now, generations is basically a positive integer, and it basically indicates the TPOT model, the number of iterations to run the pipeline optimization process. It must be a positive number or none. If none, the parameter max time minutes must be defined as a runtime limit, right? So you need to define in my generations, if you're not passing that number, then how long it's going to run, right? Generally, TPOT will work better when you give more generations. In our case, we are taking a generation size of 5, which is basically TPOT evaluates to population size plus generation times offspring size in the pipeline in total. Then over here, the next item is a population size. Over here, again, it needs to be a positive integer. Number of individuals to retain in the GP population every generation Generally, TPOT will work better when you give it more individuals to optimize a pipeline, right? So these are the things you have to pay attention while creating the constructor for the TPOT classifier. And now, before we wrap up the lecture, we have to really take a look at the stacked model, because we would be in our exercise using the stacked model and comparing the stacked model with the TPOT classifier. So in general, in stacked model, you take the bunch of training data sets. Now you pass them through different models, model 1, model 2, likewise. And this is nothing but your estimator layer. Then you have the predictions of each model, and which are basically treated with all the input features for the meta classifier. Finally, with the meta classifier, you make the final predictions. Now, in order to proceed further, we need to make the installation for the TPOT. If you are using Jupyter Notebook, go ahead and use pip install TPOT. Also for Conda, you can do Conda Forge command, which is Conda install C Conda Forge TPOT. And to install the dependencies, also you make sure you make this command line argument, which makes sure it forces the TPOT to have XGBoost as well as some other dependencies as listed over here. Now that if you are ready with the TPOT installation, go ahead and tune in the next lecture, where I would be doing the TPOT classification and comparing the stack models, and then be able to see the winners between the stack models and TPOT. So stay tuned for the next lecture. Thanks for joining. I'm going to see you in the next lecture.